You see it all right? Let me see that one off. You see it all right? Can't see it at all?
Yeah, you shut off the front.
There you go. So, thank you all for coming out today. My name is Bill Fellows. I do come to you from Kansas City. I'm going to walk all around, so your camera's going to have to be moving a lot. So, if you need to get a hold of me for some reason, you can get me on email. I blog occasionally, and if you want to tweet at me, here's my name, and here's the hashtag for if you actually want to try and stream a content together. If you guys don't play with Twitter, you should, because it's a lot of fun. But basically, new2R is the hashtag that I've claimed for this session. You good? Okay. If at any point you have questions, feel free to shout out. I'm very informal with presentations. There might be rewards in it, might not, but there might be rewards if you ask questions, even if they're silly questions. So as I said, I'm basically a database developer coming to you out of Kansas City. But when I put together presentations, I like to think about who you are, who is my audience, and basically try and get an idea of kind of where I've tailored this talk for. So basically my assumption is you're going to be maybe developers, excellent, business analysts, managers, lost, I figured that one. So anyways, basically, and Pete Townsend the Who. So anyways, my goal is at least you should be entertained by the pictures in the slides. So basically, that's kind of where I'm engaged in this. So I'm assuming you basically have some data you want to do some analysis on. The big caveat I'll make right now is we'll see a grade card that may or may not translate to my grades. I am not a statistician. Anyone a statistician in here? No? Well, I guarantee your statistical knowledge will be better than mine, but I do think R is a pretty cool language. Oh, I didn't like that. So, why I think there's value in you being here. First of all, money. Anyone do any statistical type of work right now with SAS or any of that stuff? So a nice thing about R is it's free. It's an open source project. So if you're paying lots of money that SAS or SPSS want to take from you, your company has an opportunity to potentially reduce that cost or licensing cost simply by adopting R. R is an open source statistical analysis platform. Also, if you're really good at R, there's a lot of jobs right now that are paying very well for people that can talk the talk of R. So, money might tempt you. What I think you're going to get out of this, basically, I hope that you are able to basically understand what R is, download and get it installed on your machine. You might see up there I've got a Mac running, so R is very nice because it can run on any platform, whether it be a Windows or a Linux, a Unix, Macintosh OS, whatever you really want. There's probably an installation for your target machine. Basically, we'll set up an ODBC connection, pull data out of a database. I'm a SQL Server guy, so that's what we're going to talk about. It totally is fine talking to MySQL, Oracle, or any other basically relational database provider. And then basically we'll do some fun analysis on some data. Any questions so far? So, you guys can read, but basically here's kind of the approach we're going to go through. So first of all, what is R? This or we make pirate jokes. So obviously that's the letter R, but what we're going to talk about today is the R programming language. That's their icon. Basically, as I said, it's a statistical programming language. It's fairly feature-rich as a developer. You can do a lot of things. It has some pretty interesting basic concepts for importing data, exporting data, saving images out. They've got a great built-in documentation, as well as the ability to make nice, pretty, formal-looking extracts. By the way, all this presentation plus the scripts we're going to see, I've already exported them to PDF. I assume there's going to be a facility where we can get those uploaded. If not, I can post them off my blog. So take all the notes you want, but don't worry if you miss something. You'll have an opportunity to get to it. Additionally, since you guys probably haven't seen me present before, I'm a fastidious note taker, so all my slides are probably going to have lots of notes down at the bottom, either URLs or things that I'm thinking about or what this talks about. So when you get this PDF of what we did, you can at least go back and say, oh yeah, this is what we were talking about there. So again, when I'm doing the research, I might as well write it down so that way you guys have all the same notes I have. And so basically, R is an implementation of S. Why is it actually called R? That's the two last names of the people that developed it. I don't remember their names, but anyways, that's why it's called R instead of S. And basically, it's free. So that, to me, is kind of the interesting stuff of it. So we have two ways of getting it. The first thing you're going to need is the actual R installation. So R itself is a somewhat beefy download, but basically it is the base statistical package. It's going to have the language, the runtime, all this stuff in it. And it's got a lightweight version of the editor, and you can run packages off there. Then you can also grab RStudio, which is a nice integrated development environment. So if you want a very, very lean, very bare bones thing, you can work with R, but otherwise just grab this. This one is also free, targets multi-platforms. So basically, you have to have this because that's the underlying guts of it all, but this provides a nice shell on top of it to make it easier to work with stuff. Questions? So, first thing I promised you, that's how you get it. Next most important thing is, how do I make sense out of all this? Where do I even get started at? So, these two are synonymous. You can either use question mark with whatever you want to find help on, or you can type the word help with whatever your topic is. So help standard deviation, or help this, help that. Help me help you. So I'll show you how those work real quick. You also have this syntax. You can use a double quote, question mark, or type out help.search on whatever topic you want, and this one goes to a specific topic. Find me all the information about linear regression. This is going to find me any help topic that mentions the word linear regression. So that way, if you're trying to find related items, not that the documentation isn't really exceptional and already has a lot of the hyperlinking between, oh, if you're using this, you probably also might be interested in these other 5 things. But you can't do this search because if you have no idea, I'm looking for standard deviation, but there's no actual standard deviation. Well, that's because they make it just SD because they figure that's going to be a common thing someone's going to be doing some analysis on. So we're going to do that. And they also have examples. For the way I learn, this is awesome because I just bang around and see what I can kind of figure out whenever I'm getting into a new thing, just to kind of kick the tires and understand the basics of it. So example is going to say, oh, you want to see an example of here's how we use the standard deviation, here's how we do correlation, here's how we do multivariate statistics stuff that hurts my head. But basically, you grab a thing and say, hey, give me examples of how this works versus me just trying various permutations. This will give you a useful example of how this works. And anyone doing actual, I think we already covered this. So if you're actually doing real analysis, like back home we've got a bioinformatics company there. So a lot of the research that they do, someone will come up with an interesting approach for here's how we're going to do some analysis. They'll publish their paper, but usually along with that they'll take all the R code they probably wrote and publish that out as a package. That's your quantum of stuff. So internally within internally within R, you're going to have stuff kind of segmented into packages, and packages will expose functionality. So I'm going to do some great genomic stuff that hurts my head to think about. But basically, I'll open up the genomic package, and then I'll start doing work within there. So if I want to see, does this thing apply to my data set? I'll run examples, see whether that makes sense for the kind of analysis I would want to do. Questions? See some examples? That visible back in the back row? So this here is your, this is RStudio. That's R. So they have a lightweight kind of environment, an interpretive environment. Here. So by the virtue of simply typing the word question mark, so Did I always do that? Because that's not right. Here we go. So all I simply did was type question mark and quit, because I knew that was a command I could type. So basically, up pops your help documentation. Gives you usage, arguments, everything. If I scroll way down, it'll tell you anything that might be related to it. So again, built into, and here's my example, built into the thing is everything you're going to need to know. So you can kind of fumble your way through it. There's hyperlinking within it. So, oh, hey, there's also this concept. I can click on requisite finalizer, request finalizer, registers finalizers, can't read. It'll keep linking there. So you got forward, back ways of moving throughout your documentation. So that's how we get help. You know, we demonstrate the, how many demonstrates. You can obviously do the double quotes, search through text. Example, simply show example. So the other thing that makes it fun, at least for me from an exploration perspective, so let's talk about this for a second. So there's 4 windows sitting here by default when you open it up. This is a saved text file, so this is a list of commands that I would be wanting to run. This is my interactive mode, my console mode, so that way if I just want to type something and see, is that good? I didn't do what I want. There's no reason to save it up in a file. Over here, we're going to see global environment. We'll get into this in a minute. And here you can also see some other things that we'll explore as we get through here. Basically, here's my scripts that I have. Here's an interactive way of playing with it. Here's eventually like the variables I've created, their current values, so you can kind of see how the state of values change. Over here, we're going to see some really cool things, at least for me, I think they're cool. So I'm going to type, tab is going to become your friend when you're trying to figure this stuff out. So I'm going to hit EX, I'm going to hit tab. So what you can't see as well here, basically just by typing EX, it's going to say, hey, here's everything that I think you might be wanting to talk about. Everything that starts with example. EX, example exists, EX, exponent, exponential, expand.model.frame. So whatever you want. So here I'm example, tab. So, I mean, it's already going to help you get to there. If I did obviously help example, it will tell me everything I needed to know. Run examples from the help section. So I'm going to do example. I don't think I ordered that package. That's why it's on.
Oh, Bill,
Sir.
not to point something out, but we now have a statistician here.
If at any point I say something dumb, feel free to yell out.
I'll behave myself, I promise.
No, please do.
Just don't make me write SQL.
You know, I think we might be able to get along with that one. So all they did was type example color, and it's going to give me a couple warnings here. So do you use R on SPSS?
A little bit.
Okay.
Vaguely familiar.
So what we're going to eventually see over in this right-hand corner, this is going to start generating some plots for us. So this is example of color, just a package that shows you here's all the different colors you can access and the way in which you can access it. So you'll see here, this is the code it generated. That's the resulting output. So again, example just kind of gives you a little taste of what's going on in there. And there's a lot of things that's going to show up for us. So kind of a fun thing. Again, just ways to kind of get you acquainted with what's going on in there. Questions so far? It's all right. We'll get you going. So basic data types for R. So numeric is the first one we're going to list because that is your basic data type. So they'll call them mode, they'll call them some other things within the language, but for me as a developer, it's a data type. So numeric, so something, a floating point number, something with a decimal and some numbers potentially after it. That's your default. So if you assign a variable, even if you said 5, it's going to put 5.0 behind it because it's going to treat it as a numeric decimal value. Integer, whole numbers, 1 cow versus portions of a cow. Complex, it's going to be your true false. Is this statement true or is it false? Logical, sorry, true, false. Complex is math that I didn't understand, but I still had to take a lot of it. Basically, it's if you're taking the square root of a negative number, that's going to get you a complex value going there. I've never had, since graduating college, I've never had cause to use an imaginary number, but maybe hope some of you do. And then character data. So character data is exactly what it sounds like. It's going to be a list of character or characters that we're going to assign into a string. I'm going to go ahead and kill my plotting. So, one thing I'll point out that I've kind of talked about, just getting you kind of acquainted. Again, this is our studio, so you really can't tell the difference between tomato, and Coral One. But the over here, this is where basically your plots show up. Anything that you've created as an image is automatically going to pop here. Over here, you can see that here are functions that have been defined within the context of all this stuff over here. But basically, again, just want to kind of point out, as we do things, things within the memory space, the working environment, they're going to start showing up on here. So I have reference to it. I could call show calls 1 now because it tells me this is a function. In a second, we're going to assign some variables in here, and you'll see that they're going to show up there too. So I'm just going to highlight a whole bunch of stuff, and I'm going to click. Click that, and basically the mouse over text says run the current line or selection. So basically here I simply assign so let's look at what this is doing, because this is kind of strange to look at in my mind. So 4.0 is a numeric, and I assigned it into a variable that's called numeric. 4, or if I'd done 4.0, I'm going to assign it into a variable called integer, but I have to do this. I have to say as integer because, again, by default, it's going to treat everything as numeric values. Complex, that's notation for working with a complex number. Logical, true or false. Things to note about R is it is case sensitive. So all caps true. Cap T, lowercase RUE, all lowercase true, whatever you're going to come up with isn't going to work. It's not going to evaluate to a logical, this logical thing. It's either true or false, all case sensitive. And again, if I had created another variable called capital logical and assigned it false, capital logical and lowercase logical are two separate entities. And you'll see over here, again, I promised you that as we start adding things into the stack, they're going to show up over here. So you can kind of have an idea of what all is sitting in your register, something you can easily access. For character data, you can either use a double quote or a single quote, although I think the convention is to use double quotes. And this is a really weird one. This is actually how people do assignments in R. So, the greater than arrow dash. So wherever that's pointing to is where you're going to assign it.
Is there a difference between the equal sign and then the arrow? Is one like assigning a reference versus I guess it would make a difference for literal. But...
So the question was, is there a difference between the equals and the arrow dash one? So, I love questions. Look at this. This is a great reward for an excellent question. So, no difference. It's simply syntactical sugar. Although we're going to see in a second you can do weird things with this that you can't do with an equal sign. But basically, this apparently is the preferred method. That's, however, if you're reading the documentation, you're probably going to see this in favor over that. I can type this one all day long. I can't tell you how many times I butcher this one. So just for what I'm doing, I have trouble with the dash, the arrow dash version.
Someone might have an answer here, actually, to give away things for.
No, in RStudio, if you hold down Alt and the dash, it writes it for you. Yeah, it's super sexy.
So in RStudio, if you hold down Alt dash, Alt,
It's still really awkward, but it does it for you. And if you get the hang of it.
now as we go on, it's not getting so good, but nonetheless, I'm still going to reward. Hopefully I don't beat me in the head. Oh. Really hope I remember that one. So yeah, so Alt dash will put the right thing in there. I still don't think I'm gonna, it'll be a hard habit for me to break the equals for assignment. The other thing I was gonna show, we have, if you're trying to figure out what the heck do I have, what is my data type here? We have 3 different ways of looking at it. You can do type of, class, and mode. Basically, mode's how it's stored in memory, class is the abstract type, and type of, I said basically don't ask. There's a big document, there's a big thing that kind of talks about what is your type of and how that actually relates to stuff. I haven't found a reason why I need to know it, but basically you'll see here. So for my thing that I said was a numeric, for my data type, numeric, it is a double type, a numeric class, and a numeric mode. You can, depending on what you did, those things will mess around. Only reason I pointed out to you is simply so that if you're trying to use a function and it's acting funny, check your data types versus what the documentation says. Oh, I should have been passing in integers into this thing, and for some reason I'm passing in numerics. Well, maybe that's why I'm getting an odd result. So again, you can check your.
Can you cast them as a data type when you're defining them?
The question is, can you cast them as a data type when you're defining it? You got to get warmed up now.
You got shown to as.
Yep, exactly. So as a wonderful gentleman who sure says, yes, as. So if you need to make something into a something else, the keyword is as. So
you can, even if you don't want to permanently make it there, you can temporarily make it that in a specific function. So if you want it to usually be a number, but you temporarily want it as a character, you can use it in a specific command as a character, and it doesn't store it that way, but you can do the function and keep it the way you want.
So as dot, there we go. So again, tab, autocomplete. It's gonna come up with all the ideas. Oh, you want to make it as an array, as a whatever, and there's more scrolling on that goes down there. So basically, yeah, if you want to treat it as an integer, if you want to make an integer into a numeric, just the appropriate as cast will do that. Sorry, got a very insistent friend. So the other thing, since I had a slide on it, so is kind of the, as forces a cast into one type, is going to basically allow you to, hey, is this an integer? So don't even try calling this if we don't have the right data type set up in my method. So basic operations, looks good on my machine. Typical developer cry. So normal addition, multiplication, subtraction, division, and power operations. We can do assignment either way. We can do equals, or, so, sorry, this is going to be mathematical operations. This is assignment. This is going to be your logical value. So is this thing the same value as this thing? Is this true or that true? And then you have less than, or is it greater than, less than? You can combine with an equals if you want greater than, equal to, that sort of thing. So that's your basic normal operations. Any other language you probably get these. This one's going to be a weird one. And kind of corollary to it is scan. So C is combine. So if you are just editing some data by hand, you just want to gin up a quick example, you can do combine is what you're going to do. Combine is going to make a data type of, the object's going to be a vector. So an array-ish, like object, although it's not an array because an array is going to be a special thing. But basically, a lot of stuff that's all the same data type in one of these things. So I'll show you this example of that. save them. So here's basic mathematical operations. To no one's great surprise, 5 plus 5 is 10, 4 minus 3. So you're going to notice this weird thing going on here. Every time you basically get an operation done, whenever it's printing, it's going to have one of these there. We'll get to why that is in a while. Basically, yep, you can verify that all these math operations work. Great. So I told you the assignment's kind of quirky. So we assigned 4 into the variable assignment. My variable, 3. So my variable 3, assignment you can't see because it's off the board. How messed up is this? But it's totally valid syntax. So I've assigned 5 into this variable. I have not seen a language in my life that allows a assignment to the right-hand operator. But hey, we got one here. Apparently stata or S or whatever that this R comes from allows that same syntax, but that just hurts my head. I mean, no, that's just wrong. But nonetheless, it works. So we can see that this really works. I created a variable called this really works, and it got the value of 5. Okay, so here's my logical operators. I'm testing various values of 3. Is 3 equal to 4, greater than or less than 4? I should get true, false, false, and true. Unfortunately, I did. Again, you can use parentheses for evaluation. So is this one true or is this operation true? If one of those is true, then we'll get true back. So here's the combination part. That combination operator. So C, it has to be all the same data types. So I couldn't have mixed and matched and done a 1 and an A and a 3 because it's going to say, no, they all got to be consistent. You'll see here again with my strings, I could use either single or double quote. Again, the preference, the style guide basically says use double quotes. And again, just sort of that, so we'll create X and Y. So now, this looks a little bit different over here. So I've got X and Y. It's going to show what the basic data type is, number versus character. And we're going to have elements 1 through 6 and 1 through 3. So I created, as I said, a vector in X or Y that has elements that I can go from here. Here's the actual values you can see. So I can address into these vectors if I'm so inclined. Make sense so far?
If in the second case, if we add a numerical value, will it do automatic typecasting?
So the question is, in this example, if I add in a numeric value, so it, I believe, it decided to interpret for their typecasting rules. The question was, what happens if we do this? It could promote that up to whatever the other data types are. That's worth candy.
Thank you.
In my examples, in my sessions, it pays to be one of the first questions. So yeah, it'll try and promote it up. If it can't, it's going to blow up. Or it's actually going to, not blow up, it's going to assign in an NA. So they have special placeholder for not a value. I'm sure I'm not going to get checked on these. And scan basically, I don't have a demo for, but basically you can basically say, hey, I'm just going to scan, and I'll just start typing things into the editor when I'm done. It'll kind of return that back to whatever we're signing it into. So just a different way of doing it. There's lots and lots of different ways of getting data into R. So again, just covering some of the basics of them. Any more questions? You guys are going for me. It's good. So another way, you don't even have. Again, I go for entertainment. You don't even have to have. You only have to work with your own data sets. There's plenty of free data built into R. In fact, most of the packages you're going to install, they're going to have their own sample data sets, reference data sets. So you can just, again, so you can kick the tires and make sure it's working. So the two things we're going to talk about here is data. So basically, this will tell you, here's all the data sets I currently have loaded and available to you. And then demo is going to kick off some demos of whatever you want to see. Everybody saw it.
Yeah, too excited to show it.
So I'm just going to type the word data down here in my console. Actually, I'm going to type that. I'll hit my tab. Again, just to get you, as you're working through it, just start exploring, just play, see what you can find. So up pops this window, and it's going to tell me, here's all the data sets that I currently have and kind of a description of what they are. So, of great importance to the world is chick weight. So weight versus age of chicks on different diets. We also have some really, really interesting data sets in here. But nonetheless, girth, height, and volume for black cherry trees. They're very specific data sets, which is, I think, actually pretty cool, but you know, you just kind of have to figure out what in the world are sunspots. Are they anything that's actually useful for me? I think we have presidents in here. Probably scroll past it. So it'll show you their popularity by quarter of presidents. Quarterly approval rating of U.S. presidents from like 40s to 1980. So again, lots of built-in data sets as we load packages in. So if I look at packages over here, again, packages are basically there are some that come built in, others we can go and grab. Usually they're free, they'll all come off that one website. But basically this tells you, hey, here's all the ones that are currently loaded for you. And so when I run that data thing, it goes and asks all the packages, hey, what data sets do you have to present? What do you have ready? What do you have available to you? So if you want, if I load in spatial, now all of a sudden if I rerun data, I'm going to get a new set of data sets available to me because someone wants to demo whatever showed up in data. I don't know what's in data, or I don't know what's in spatial. That's going to now have shown up in here, but hey, it's now available to me. So again, it's just kind of a fun way to interact with the thing, just to get a taste for what's going on in there. So, any questions about some of the data? So again, you can go play with whatever packages you want. Otherwise, we'll start moving on to some analysis. So, our standard things, so we'll take our mean, our standard deviation, our correlation between them, or you can just kind of cheat and just say, hey, I'm going to call it summary function. It's going to basically look at all the data you pass it and try and figure out what data you got in there. So again, statistics are not my thing, so we're not going to try and do any deep, insightful work on that. But I will at least show off some cool things. So I am going to create a variable called courses, and I'm simply going to read a CSV straight in, built into the language. Read.csv. We also got read. Lots of different formats. So if you get flat file formats, natively, easy piece of cake, we'll read it on in there. We can skip this next part. It's simply me messing with stuff. So I'm going to read in this file, and it's going to generate, since I said print, it's going to do some basic, this is just going to print the data as I read in. So it already knew, it was able to read my column headers in. You'll notice that, so in my file, it'll be catalog space number is the column name, but here to make it a valid, to comply with our syntax or numbering type of stuff, it's going to put a period in there to make it a good name because it doesn't want the space in there. So we're just going to run summary, because I'm lazy. And it's going to look at all that data. So let's step back a second. We have courses over here in my environments. You'll see now we've got our data, we've got values, because those are my local variables, but the variables I define, whether they're regardless of their types. Here's the functions that we help define. Now we've got this data thing. So this is called a data frame. And that, to me, is the thing I work with from a SQL Server perspective day in and day out. It's basically a grid-like type of thing, so rows and columns. They have special names for them. They have your row name and basically your observations and whatever the other word is. Feel free to shout out if you know the word I'm trying to think of.
Variable?
Yeah. Yeah, so just kind of a different syntax, but it's rows and columns. And so here I can kind of explore through and see what I have. Or I can print it out and do the same for, this is all the values. When I do summary, it basically tries to figure out, hey, what do you have in here? Do you have anything useful? It tells me how many observations. So I had 2 comp sci classes, 7 math, and 1 stat. Here's their numbers. There's nothing really useful from an analytical perspective. When we get down to things that are numeric, I think it's a little more interesting. So for my credit hours, Yep. So my average was a 3-hour credit class, something or more. My minimum was 2. My max, I had a 5-hour credit class. You can see what the grade distribution was. Hey, you know what? My math score is basically 2.2. So I'm not a strong math major, but nonetheless, it's there. It's something, you know, I didn't have to do anything. All I just did said summary. Go figure it out yourself. I could have individually called this, so I can do standard deviation on my courses tab. I want to do the standard deviation of my courses for my grade point. So within what you can't see on the screen, basically there's standard deviation, which is probably listed up there somewhere, or not. So you can do some simple analysis on your stuff. We have standard deviation. You can also get into plotting, which you saw a bit with the color demo. I'm going to run this. So I'm simply going to figure out what my GPA per credit hour is. Generally it was 2.17 because, goodness gracious. Got a weird zoom on it. So simply by calling plot for what I want, yay, there's my grade. There's my college transcripts. 2 hours, 2 hours, 2 hours. Oh, hey, 1 crazy A, and then everything else went back down to 2. So again, if you came here for statistical math knowledge, no, you're in the wrong place. But it is fun to see how R does some of this stuff. Now the important thing I've learned so far, is a basic lesson. Whenever you're getting data in, the very first thing you should do is
Check it, make sure it's right.
checking to make sure it's right, yes. The other thing is plotting. So there's a really cool data set. Again, it's going to be built in there. We're going to be working with the Anscombe Quartet. So it doesn't matter what this stuff does. Again, you can see all this fun stuff. We're going to so this went and loaded up the Anscombe Quartet and did some analysis on the data. So what we're going to see here is basically for my X and Y values, they all look, the standard deviation, error, all this statistical stuff. It's going to look very, very similar. So therefore, all this data is the same, right? Right? Of course, you wouldn't be demoing it if there wasn't a point to all this. So, as it says, the first thing you should have done was plot your data. So what we should be seeing is the fact that these plot very, very differently. You know? Dropbox. All right, well, we're gonna punt on that one. Maybe it was clever because you'll see that they have different factors going. One's a nice linear plot with a single outlier. One's not a linear, but it's still going to plot out those. Anyways, it's a famous thing, and I butchered it. I have no idea why it broke. Beautiful thing is, we can go on to the next one. So again, the takeaway there was plot your data before you go making any great conclusions about what your data looks like, because just because one data set's going to look very similar to a data set from an analytical perspective, that doesn't mean they actually fit the same data model. And that's about as close to statistic stuff I can tell you. How are we going to do that? Well, the basic library is going to be called plot. You can call it plot, whatever data set you want to throw in there, and it's going to try and make heads or tails of it. You have quick plot. So plot's built in. A package that I see a lot of references to that makes gives you a lot more control over your plotting is the ggplot2. So basically there's a package, you go out and you grab it, you'll find a lot of documentation on it, a lot of people are using it, but basically they've got two versions. They've got a quick plot version, and we've got the kitchen sink where you can finagle every minor detail of what you want to see in there. So I want to show off that one. So I keep talking about these external packages. You want to be able to get them. Usually with whatever you're grabbing, they'll kind of indicate here's what you need to have. So if I were connected to the internet, I could run this command here, install.packages rcurl. This will go and grab the package. Again, it's going to be case sensitive. It's going to go grab rcurl so I can do some stuff. I'm then going to, it's going to download it and get it ready and installed, but it's still not in my workspace. If I look over here, I'll show you in a second, I don't have either rcurl or ggplot2 sitting in this checkmarked location. And I can manually click through this. If I look at my packages. So you can see that rcurl and my ggplot2 are unchecked. Maybe why my other thing didn't work. So now by virtue of running this too, despite some warnings, it's going to say that basically it loaded up those two packages. So now if I can look back in my, if I look at my packages list, now I'm going to see that ggplot's been selected. So this is the programmatic way of pulling it in there. So if you have a script that you want to make sure everything's set up right, have these commands sitting in there. So again, this grabs something that may not come standard, may not be part of the vanilla install. This is how you get it into the current memory space so you can reference stuff. We had this fun conversation about, hey, do you need to have wireless turned on? I said, of course I don't, except I forgot this demo. So what we're going to see here, as soon as I drop the hotspot, I'm going to be able to pull data out of a URL. That comes native. Well, grab rcurl to do it. But basically, it can natively read stuff off of a web page. It can go out and grab a data set from some external source. You don't have to do any of the screen scraping or any of that painful stuff. If someone's got a CSV post out there, you don't have to write an FTP task to go and download it and put it into whatever stuff. You can simply say, hey, go grab this content for me. And let's get some free key. While that's connecting, yeah, so yes, my wireless hotspot is free candy because I always like to make it a gamble for people to see, like, huh, do I connect to that or do I not? It sounds kind of spurious.
guest Wi-Fi information up on the board.
Yeah, but that's more work.
Let's try this one more time, and if not, we'll come to move on. And so while we're working this, I'm simply going to sign in this URL into my file path, and I'm going to read CSV. The value of my text is simply going to be that URL. We'll come back to this one if you guys really need to see it connected to the internet. But it is amazing. I think that it's just built in. If I was doing this in .NET, this is going to be a lot more trouble than I want to deal with. So basically, read in a CSV from a remote location. Hey, we're using tab as separators. One thing to note from a file pathing perspective, in Windows, we use backslashes. So C:/users/bfellows. In R, regards to whether you're accessing a URL or a file resource, you're going to use the Unix syntax, which is going to be /. So even though you may copy your directory location out of Windows Explorer, you're going to have to change all your backslashes to /. Otherwise, you're going to get unexpected results because the backslash is a C holdover where basically that's going to escape special characters. So the /t is a tab. So here we would have read in my data. This would be a simple, as my notes say, we got histograms, we got scatter plots, we had all sorts of fun things about this tribal data. Let me see if I have this installed. No, I don't. So anyways, sorry about that. So that's how plotting can work. So you can have very simple plots like this, or you can get in really detailed and address your facets and what colors you want and all, or what data set you should use for your color and all sorts of fun things like that. So you can make beautiful graphics, or to not that one. Come here and go demo ggplot. Not my name.
Why are so many companies looking to hire IT Tech grads?
That's
From
why we
ATMs
have
to
deviate from
airport
this
checking
script.
kiosks, NCR.
So again, we already talked about C. We're going to combine, be able to combine stuff together. Scan, you can also scan or read in from a file. We just demoed, in theory, read CSV, regardless of whether that CSV is a local resource, a URL resource. Thing to note is NA is going to be your not available value. If you're reading in a CSV and you're missing data there, it's going to stub that in for you. Or if something weird happens, basically, you have, whenever you're importing and dealing with data, you need to be aware, what do we do when we have no value available? So again, you need that from a statistical perspective. You do an analysis on your data. Maybe you do need to count those. Maybe you don't need to count those. So you'll usually, with all these methods, you have an NA. There's a Boolean value you can set. Basically, hey, what are we going to do with these? You have a Boolean flag you can set. What do you want to do with your NAs? Kind of the point I want to make on that one. So we saw data types earlier. So really what we're seeing though, we have some more complex data types. We've got our vectors, matrices, arrays, and data frames. Data frames we saw, that was the CSV data we loaded up in a minute when we connect to a database. The data that comes back is also going to be in a data frame. A data frame is rows and columns. Columns got to be all the same data type, but you can have different data types within. Each column can be its own separate data type, but all the data has to be homogeneous within it, but it can be heterogeneous across the row. A vector is going to be a single data type. It's basically a one-dimensional, however big you want. And one of the things that I didn't tell you is every data type, all those scalar values we looked at originally, they're actually a vector of a single element. So whenever we would print, whenever we would access one of our 1D variables, like this assignment here, this value sitting right up here, so my assignment has a value of 4, and it prints back 4, but really it's saying, hey, the very first element of this vector, of this one-dimensional thing is, there's only one, it is a vector of one dimension, of one element, and its value is 4. So if I had multiple things, if you saw back when we did my courses, when we talked about that, it would say, hey, there were this many observations sitting within that thing. So you've already been seeing you've already been seeing what a vector is. You just didn't know it.
Question, I've seen this and I've never understood it. Got the values, you put 4 under assignment, so it shows you 4. But you also called 4 integer, but over there it shows 4L. What's the L mean? Is that something about it being a vector or not a vector?
So, question, now we're down to the
Last,
oh, sorry, you need another one? Okay. So the question is, why does this one have an L and why does this one not have an L? It's totally your data types. So this data type, L, at least to me, is a
Long or double?
yeah, thank you. I was trying to think of what language I wanted to pull out, but yeah. So basically, this is your whole number. That's an indicator to say this 4 again by the default it's going to be a numeric. So even though we don't do 0.0 behind it, it's sitting there, it's hiding in the background. Whereas these it's going to say, hey, don't mistake these for not being don't mistake these as numerics because hey, they're actually they're integer data type. They're a whole
Is it
number.
integer or is it a decimal type?
Well, that's a great question. Let's find out.
Is it a decimal?
STRI. It's an int.
I think it's an integer, because just thinking like today I saw this one, what is this? I was using an count function, so it probably automatically knew it was counting something unless we did an integer automatically.
So exactly. So again, I don't have to wonder. I ask it, say, hey, what is your type? So I simply call the string method on this variable. It says, hey, it's an I and its value is 1. Do a string method on the assignment. It says, hey, this is a numeric data type 4, which is kind of how you correlate that back to what you see over here. Great question though.
So are all of the integer data types in R big ints? Do they overflow at 4 billion or do they go on forever or something in between?
Question is, are all the data types in there big ints, which or something else? I don't know. What can you?
Sure. Don't hit the camera.
Thank
Thank
you. If not, it's
An L would definitely imply a fixed sum. 32, 64.
I know I saw somewhere in there, I think where you can tell you what the sentinel values are, what your max and min are, but I don't remember where that was sitting at. If not, documentation. I'm not going to look at documentation. I really want to, but I'm not. We're already kind of running along. So simply what I want to talk about, simply on vectors again, you're already using vectors even if you don't know them. A matrix is simply going to be a two-dimensional thing. What's kind of weird about by default when you're filling up so if I do, we'll do it right here. Do a new. I'm doing a vector equals, so I'm going to do a vector from 1 to 11. I highlight that and run, so now I'm going to get something popped over to here. So this is a shorthand, number colon to another number, but basically saying give me that whole range rather than having to do 1, 2, 3. So now if I print out D, I printed out D. You can see it's a vector. There's only one element in it, and it's all these. That's wrong. That's that.
If you got it to go down another row, it would give you the number that element was. Just tells you the number of the first one.
Yes, thank you. Sorry.
So you're like 1 to 100 and it'll do it.
Not be constrained by your 100, I'm going 101.
I respect your choices.
There we go. Thank you. So,
0, 1.
so that's, we filled in a vector. Now if we make it a matrix, assuming I didn't break that, colon C, we looked at N, so the principal, it's going to fill not as I would expect it. And that didn't fill it at all because I didn't set the number of columns. This is where I need my, that's where I don't go off the reservation for what I'm doing. Basically what I was trying to show, because my brain is blanking on the right syntax, basically when you are setting up a matrix and you're filling it, it's going to fill column 1, row 1, column 1, row 2, da da da. It's going to fill in column-wise fashion versus row-wise fashion. You can
It's just N column, NCOL. It's not getting you, yeah, there it is.
close 10. Now if we look at them, English could be. We're not behaving. Okay. Anyways, short of what I was trying to simply show is it'll tell you, I simply want to show you how it's filling in. Again, I have some rusty spots to work out on this. So one-dimensional, two-dimensional space, any more dimensional space is going to be your array data type. Generally, from what I understand, you're working with, to me, I'm working with data frames for what I've been playing with. But you need to look at whatever methods, whatever analysis they're going to be working on to figure out what data type they want to get, they're expecting in there. Questions on this part? I hope not.
Just a quick comment, I did look up the integer and there is a limit of 2 billion plus or minus 2 billion. So
There is a limit of 2 billion plus or minus. Thank you, sir. So one thing I wanted to point out is if I want to grab items, again, it's a one-based ordinal system. I wish to all whatever deities you want to talk to. I really wish people would get consistent and everyone use base 0. But anyways, so the 0th element is going to be, you can, so a 1 or a 2. This is going to grab these 2 elements out of that whole vector. This is going to grab you a range. So if you do a negative slice, basically that's going to remove an element. So if I did -2, if I had an array, if I had a vector of 3 elements, if I do vector -2, that's going to remove that second element out of there. So if you got stuff in, like you loaded some data, you did a little data quality, yeah, what was this? That's a way you can remove that thing from there. So basics, that's how we're kind of working around with R. It's going to get you a lot of kind of the basic boilerplate for it. So again, I work with SQL Server. That's my day job. This is more just fun stuff I want to play with. If you want to be able to connect to SQL Server in a Unix world, you need to get free TDS. I've got that installed. You have to download it, compile it, make it, do all that good stuff and install it. And then you get to go through an additional level of fun, which is dealing with ODBC libraries in the Unix world. I still haven't gotten that to work yet. So we're going to cheat at this point, and we're going to use a Windows version of RStudio along with Windows versions of ODBC because it's seamless there. It's so nice and pretty. But basically, you have two options for working with data in SQL Server or a relational database management system. Generic database management, RODBC. So run this command, it'll download and install the packages for you. Again, in some notes you can't see that are linked in the documentation here, there is also an RSQL Server, lowercase. And that is someone's version of a high-performance interface into and out of SQL Server. And yes, you can push data as well as pull. You can pull data out of SQL Server or relational database as well as pushing it in there. So I don't know why you'd want to inflict that pain on yourself, but nonetheless, you can totally do that. So these are your basic ODBC commands. So the important thing you have to do first is basically open up a channel. And you're going to open up that. So a channel is literally that. It's going to be one connection that's talked to the database. That's where all your communication is going to go on. And when you're done, close it. Otherwise, someone's going to get mad at you. Because basically you're keeping a resource tied up until the program goes out of memory. So you've got fetch. And basically it's going to take an argument of here's my channel and here's the SQL table. The SQL table, so fetch is you're going to say, give me the whole dang thing, all the columns, everything. That's extremely wasteful. Don't do that. Instead, write queries. I'm a firm believer in queries, regardless of what you're doing. So craft your query. I only want the data for 2014. I only want this column. There's no reason for me to pull all of this data because the more data you pull back, the longer it's going to take to transfer over the network, the more memory it's going to take, et cetera, et cetera, et cetera. So that's query. If you need to update, I don't know why you want to do this, but nonetheless, if you want to write a full GUI that's talking to a database, you can totally do it. So let's see what that looks like. So here's RStudio on Windows, RStudio on a Mac. They look the same. Great for cross-client compatibility. So what we need to know about working with the database. So here I am in SQL Server, or on a Windows world. I'm simply installing my packages, RODBC, all caps. I already did that. I'm going to load the library into memory. I'm going to set up a DSN. So Windows has ODBC drivers, Open Database Connectivity, ODBC. They come in two flavors. You have your 32-bit and you have your 64-bit. You have various providers. IBM's going to give you a DB2 ODBC driver. They only give you one flavor. You might get a 64-bit. Most likely you're going to get the 32-bit version of that. So if you create a DSN, if you're not paying attention, you may try and create it in the 64-bit space. But the ODBC, if you try and reference one that's in 64-bit space, you're going to say, I can't find that, because you have to get the right version of ODBC to match to your version of RStudio. So here I'm running a 32-bit version of RStudio, I think, and therefore I'm going to be looking at my DSN that I created in the 32-bit space. By the way, if you're looking on older versions of Windows, but still 64-bit, you're going to find an ODBC wizard thing sitting in sys32. And of course, as we all know, system32 is the 64-bit folder location. There's a syswow64, which is actually the 32-bit driver space. So odbcad.exe and system32 is 64-bit, and the one in syswow64 is 32-bit. Scott, would you like to say anything about this?
I think that was worth the price of admission. I mean, that could keep you going all day.
Yeah. I never had to deal with any madness. Like, why? It's installed. Yeah. So in your here in
So does anyone know what WoW stands for?
World of Warcraft.
So Paul got it. It's Windows on Windows. So if you actually say it out loud, it kind of sort of makes sense. It's Windows 32-bit on Windows 64. So the 64 is attached to the second W. So it's the 32-bit Windows on Windows 64.
So you also.
It still doesn't make that much sense, but-
Yourself in the place that They were trained to apologize for some mistakes, so.
So I am in Control Panel, Administrative Tools. So again, you've got two different flavors here. Earlier versions of Windows Server, at least, they only showed the 32-bit version, which was, of course, they only showed the one that was actually in the 32-bit space, which was really the 64-bit. And then again, since IBM only gave me the 32-bit DB2 driver, so I didn't have. It took me long to figure out, and then trying to explain it to DBAs who really didn't care. That was a new level of fun. So you'll see here I have created. Oh, take that back. So I've got. Didn't expect that. Still getting used to Windows 8. So here you can see I've got my AdventureWorks DSN, and since I'm using an ODBC driver for SQL Server, that's going to be in 64-bit space here. I've also got one that's in Azure, it's in 32-bit space. My RStudio is a 64-bit installation. Somewhere in there. So anyway, I'm going to load up my library. I'm going to zoom in. Open my connection channel, and I'm going to pull my data back. So I've got a query here. I'm going to pull back my subtotals from stuff, and I'm going to explicitly cast this into a matrix just to make sure everything goes well. And then I'll, again, just run my summary on it just to get some information back. So yay. So here's my, I pulled back 3 columns from my query, which is now off the screen, but basically subtotal, freight, total due, and then I just did some analysis figure. Hey, just let it run with the basic analysis. What if you had a real pressing concern, you wanted to see what's the linear fit of this stuff, you could pipe it on in there, but again, cheap and dirty, that's what I was about tonight. Oops. No one slapped my hand for not closing my connection. Oh. So, here's the 2 books I've been reading on this. R in Action. I found a really good book. Beginning R is just as good. There are plenty of free resources. You don't have to spend a dime. You'll see there's lots and lots of different things that I looked at while I was putting together some of this article. All this will be clickable. You'll have all these notes here. And any questions? Yeah.
Why is RStudio free?
Why is RStudio free? Oops, sorry. So it's free because they make, so the company that's putting out RStudio, they've got a server version of the product. So you can basically, so right now this is running on my desktop. If you're doing heavy number crunching, you're probably not running it, you're going to go run it on a server. They want to talk to you, they'll give that away for free because they want to talk to you about getting a server installation up and running. So I assume that's why it's free. Maybe they're just extremely generous souls. I don't
Are they a pretty strong company? Are they going to be around 5 years from now or 10 years from now? Or?
I don't know that anyone's going to be around for 10 years from now, but ours is going to be around. So if someone of course did an analysis of papers that have been published on various topics that are all statistical based, and basically the number of articles is just accelerating, especially that are supplying, hey, here's my analysis, here's my new way of analyzing this weird data set or this special trend or whatever. Here's the accompanying R to it. So I don't see the momentum for R slowing down any bit at all.
So in the R compiler and runtime is actually an open source project. And then RStudio is a proprietary product that gives you the better developer experience around it. So even if RStudio isn't still around, you'll still use R, but with somebody else's IDE.
Yep.
Yeah, RStudio doesn't actually, they don't provide R. R is like, it's just a pretty face on top of it.
Yep. So this is exactly what Scott's saying. This is basic R. the basic interactive environment, it's going to be around because it's open source. So you could take over maintenance of it. More questions?
And how much of the punishment?
Sir.
Can we, from the R Studio, if you want to export it to Excel and all that, can we do it?
Question is, can you export Excel to R, or R to Excel? I would assume so, since Excel, believe it or not, is an ODBC. You could talk to Excel. I'm not going to talk about what I think about Excel as a data carrier. But yes, you can talk. You can since it's ODBC, you should be able to export to Excel just fine. If I had gotten any of those printouts to work, you can also export to PNG, PDF, whatever you want to do with your data. But yeah, you should be able to do basically open up an RODBC connection to SQL Server or to Excel and pipe it out into one of those.
I saw that you had some graphics with R at the beginning. Can it also do a GUI interface?
Yes. You heard of Shiny?
Question was, can you do a GUI? And the answer is yes, and something about Shiny.
So RStudio has a lot of like the top-notch developers working for them. Most notably Hadley Wickham, who came up with ggplot, which he showcased. And they've come up with a way to write very simple text that develops applications, and it allows you to interact with your data and have drag bars and click on dots. And you can make, right now in my world, there's a lot of resources being developed for internal reporting being deployed exclusively in R with Shiny. You can leverage all the statistical power and have a GUI interface without having any .NET or JavaScript knowledge. So.
Can you compile it?
So yeah, you don't need to compile it, right? It's just high level. All the heavy lifting, compiling of code is all done. Actually, there's a package now that lets you write C++ code, and without a compiler, it just does everything in the R engine. They've written a lot of packages to do that.
That's very here. Yeah, they've also got what, Knitter and all these other.
No, yeah.
There is just a groundswell of people coming up with crazy ideas. Well, not crazy, but good ideas of how to extend. Oh, here's the itch I need to scratch for all this. So they're integrating it across lots of things. I just think the graphics are fairly compelling. I don't like working with SQL Server reporting services as much as I probably should. So I was like, ooh, these are pretty, and I can make quick exports out of that. So, and I there are a lot more basic reporting elements available to me. That's actually why I got started. That's why I got interested into looking at this.
And a lot of what they're working on now is leveraging the D3 libraries of JavaScript so that it works well with web integration. And so, like the what's it called? The plotting feature of that lower window, that's an R kind of object thing. It's very awkward to get to fit within other documents, but once you leverage D3, and there's a package called ggviz that does all of that, it becomes much easier to kind of scale out your projects and use R.
Good discussion. Yes, sir.
Once we get the data into R, is there a way to cleanse it and all that? If you want to do a data cleansing, is there a way to do it? Like remove some rows or do something?
Yep, there's full data cleansing available to you. I mean, obviously you're writing it unless there's pre-built. There may very well be pre-built packages. Again, it's a wide network of library. If here's what all you can do, but for basic stuff, I mean that's part of your input routine. You're going to pull some data and you'll do some analysis. Maybe you can spit it out to an intermediary file because maybe it's going to take so long to do all your analysis. At least that way you get all your data cleaned up and ready to roll. Questions? Any more chocolate? Anything else? Plenty left. Knock yourselves out.
Do you know if anybody's done an SSIS component yet? Basically, just run R queries against a data flow buffer, or R, I guess potentially multiple R statements in R snippet, let's say.
I'm not aware of anyone, but I'm going to go bingo that as soon as I'm off mic. No. But
If not, maybe we should write one.
So you could definitely do an execute process task to fire up the interpreter, but
and then you got to ship data to it. So
yeah.
So we had an integration problem where I worked, and we actually figured out a way that we could call the command line within a SQL stored procedure, and they opened R and executed a line, and the last line wrote out the data that we used. So the SQL query compiled the data, processed the data we needed to put it into a table. The R code grabbed that data, did what it needed to, and then wrote back to the table the data that only R could provide. And then that fed into production processes for the day. So, like, there are ways, it's kind of a, there's not a lot of really great interactions with SQL Server. I've never heard of our SQL Server, so huge value to me.
So, in that, there was some,
I use the open process, open query.
Yeah, we just use RODBC. Yeah, open query.
Open query, you can, yeah.
So-
Yeah, I've found it on my phone.
Okay, oh, so yeah, so this one,
French.
yeah, they were having a bit of a body part waving argument on Stack Overflow about what's the best way of doing all this stuff.